429. Write a nuclear reaction for each step in the formation of 218 Po, so polonium, right, from 238 uranium. And this proceeds by a series of decay reactions involving the stepwise emissions of alpha, beta, beta, alpha, alpha, alpha particles in that order. So basically we have to write each step nuclear reaction. They tell us what we're emitting, and we want to form this at the end of the day, and we're starting from uranium. So this is our starting material, and this is our ending. Now, I do notice that the question here states that uranium is 98, but I think this was maybe a little bit of a silly little typo in the textbook, that uranium is never a 98 atomic number, right? Uranium is always a 92, and I know that because atomic numbers never change for their elements. And if I'm just looking at my periodic table, which I have whipped out in front of me, I see that a U has a big fat 92. So that's what I'm going to do. I'm going to do it with uranium as being a 92 and not a 98, because the 98 isn't uranium. 98 is californium, which is representative by California. But anyway, so we're going to take the uranium 92, the 238, the mass, and we're going to end at 218 polonium, PO. Polonium, polonium, polonium. So let's start it off. Now, just know that all of these steps are emissions. Emission reactions are when your particles, whatever they're telling you what they are, these are always going to be released into the atmosphere. So your particles are going to be always in your products. So that's a good thing to know, because if they say beta emission, you know that a beta is going to be in the products. Alpha emission, positron emission. So just watch out for that word. But now, let's do our steps. So we have step 1. Let's whip out our nuclide notation. We got the 3 boxes. And we're going to start from the uranium. So capital U, 92 is what I'm going to do, and a 238. Okay. Now we know that we are going to emit out an alpha particle, because it said that we're doing it in that order. So alpha goes first. So we're going to say that this is an alpha particle, but then the question is, what is an alpha particle? Alpha particle is a fancy way for saying that you're just emitting out a helium from your atom. So you can say alpha here, or you can just say He. Maybe I'll just use the helium. And it's a helium, always a mass number of 4, and helium always has an atomic number of 2. But now the thing is that, remember that the mass number on the reactant side have to equal the total mass number on the product side. This uranium is going to change into another isotope. So we have to find out who that is. So let's get out our notation again, and let's see. 238, you could always view this yield sign as an equal sign. So 238 equals 4 plus what? If I subtract 238 from 4, I get 234. And I'm going to do the same thing for the bottom. 92 minus 2 is a 90, because 90 plus 2 is 92. But now the question is, who is this isotope? Always the atomic number will tell you who it is. So on the periodic table, I'm going to look for number 90. And 90 is thorium, TH. And I have my first step, so I'm going to throw that over here. Now, we're going to do step 2. Now, from step 2, since this is a, step-by-step process, you take your isotope that you just made. So in this case, I'm going to now take my thorium, which had a 234 atomic mass and a 90. The alpha is done. Now we're going to go beta emission. So let's see, what is a beta? A beta, so we'll say beta particle. A beta particle is a fancy way for saying an electron. So whether you want to put the B or you want to put a E is fine with me. I like to put the B here. And just know that any electron or beta particle has a charge of a -1. And since betas or electrons are not in the nucleus, it's got a big fat 0 for the mass. Now, once again, we just have to find out who is the thorium going to be changing into. Let's see. 234 equals 0 plus, well, 234. And then 90 equals -1 plus what? This would have to be a 91, because 91 plus a -1 is 90. Look on the periodic table to see who 91 is. And that's protactium, Pa. All right, step 2 is done. We're getting the hang of it. So let's keep going. Step 3. Step 3. That is a beta. So we're going to do the same thing. We're going to pick up where we left off. We got protactium, Pa, 234, and a 91. Now it's going to be emitting, where are we, step 3? Another beta. So let's bring in the beta again. 0 and a -1. And now let's just find out who that isotope is going to be turning into. 234 equals 0 plus 234. 91 equals -1 plus, this is a 92. 92 plus a -1 is a 91. So we're back to uranium. Seems like we didn't really go anywhere, but I mean, we lost some mass. So that's a win. Let's now do step 4. So this is out. So now the rest of them are going to be alphas. So step numero 4. Let's bring in the uranium, which is a 92. 234. We are emitting an alpha particle. So that's a helium. 4 on the top, 2 on the bottom. And let's see. Oh no! We're going off the screen. There we are. Okay. So let's see. 234 equals 4 plus 230. 92 equals 2 plus 90. And 90, we're back to thorium. Okay. I mean, we're getting somewhere. Let's see. Can I throw this down here? Beautiful. Another alpha. So step 5. Pick up where we left off, which is the 230, 90, TH. Another alpha. So we're going to emit another helium. 4 and 2. And now let's see what that isotope turns into. 230 equals 4 plus 230 minus 4 is a 226. And then 90 minus 2 is 88. We're getting there. 88. Who's 88? Looking on the periodic table. Radium. Ra. Okay. Step 6. Pick up where we left off. Ra. 226. 88. Another alpha. This should be the last one, but I don't know. There might be another typo. This question's crazy. 4 and 2. Let's find out where we're ending here. Technically, by this stage, we should be ending at 218.84, but when we do it, 226 minus 4 is a 222, 222. 88 minus 2 is an 86. And that's radon, which is Rn. It seems like we're 1 alpha away. So I believe what happened here, we also needed to add 1 more alpha emission. Because if we add that 1 extra step, right, step 7, we pick up where we left off. So we got RN, 222, and an 86. If we emit 1 more alpha, so 1 more helium with a 4 and 2, and we see where we end off, 222 minus 4 is a 218, and 86 minus 2 is the 84, and that's your PO, polonium. And that's where you're ending here. So I believe here, 2 things for this one is that shouldn't have been 98, you should be starting with a 92, and we should have to add 1 more alpha emission, step 7, to get the final answer. But other than that, it's a good. It's a good. Anyway, I hope this helped. A lot of practice with writing out equations, so this was a really good practice question. Thanks for coming here. Thanks for hanging out. All right. Love talking to you guys. And yeah, if you haven't been a subscriber, if you wouldn't mind pressing the button, that would be great. Thank you so much. If you want to become a member, you can to the channel. There's different perks, little extra stuff that we want to give to you guys if you're interested. But yeah, either way, I hope you're having a great day out there. Keep studying hard, and I'll talk to you in the next one. Bye-bye.